for everyone watching this. You've got a ton of different projects running on this Kubernetes cluster, and it's like it's been absolutely a godsend for this server.
Yeah, so I started using Kate's at work when we needed to run some infrastructure for our IoT platform at scale and with high reliability. Kubernetes came on the scene maybe a couple years before I got into it. I mean, it's been around for a bit, but popularity wise, it was really popping off uh, when I started to get into it, maybe around 2018, 2019. So it's gotten better ever since. And I showing you some of the stuff on the cluster here,
Yeah.
some of the people in the uh, comments or the chat rather, were saying that, this seems like really heavy for something as small as 1984 bot.
Yeah.
And I agree, given that, 1984 bot is just like one small app. There's only a couple of services and you don't have that many users. So if you were doing this for a professional job, putting something together for a company, you might not choose Kubernetes because that, ends up being an expense that they'll have to deal with later. Their own internal IT might be better suited for just hosting on a single instance somewhere, maybe Docker Compose. But I like it because, as you can see, I have a whole bunch of projects and I'm able to host them on the same cluster. And I don't really have to worry about managing multiple machines. I can just take a peek here. So I have K9S mapped to WP for watch pods. That's kind of an old shell alias that I've been using for a while. And the dash uppercase A shows all namespaces. So, uh, so where do you want to go from here? Do you want to talk about individual projects, or you want me to go through these namespaces?
Yeah, I mean, it would be cool to see the individual projects and like what components of them. Like some of these projects are pretty involved in terms of having like authentication servers and backends and front ends and then a bunch of auxiliary stuff. Like um the Synapse backend seems pretty complicated.
Yeah, and there's a whole bunch of services
Yeah.
to it. Seer is also pretty wild. Let me see if I can start that up actually. Uh, so basically, we're almost there. Well, I'll show you Seer as well. So the trick here is making all of these services stateless. In other words, you're not attaching like a volume. Uh, when you delete and recreate a pod, it wipes away all of its memory. That definitely simplifies what you're doing on the ops side. Out of these microservices for Synapse, I think, yeah, every single one of them is stateless. So that helps quite a bit. If you don't have stateless services, it ends up being a little more complex. Like here is my Keycloak deployment in the Keycloak namespace. This is what we use for user authentication. Oh, I'm starting up that other cluster, so I need to pass tauntites here. So we have Keycloak operator, which is going to, I'll show you my DevOps repo. I've got a private DevOps repo here that I put cluster specific stuff into. The operator for Keycloak watches for these Keycloak resources on the cluster,
Yeah.
and it creates the Keycloak cluster. and response. So standard Kubernetes architecture where you have the specification portion of the resource, and then the controller. Let me see if I can show you controller logs. I'm pretty sure I can. I don't think there's any like sketchy stuff in there.
Yeah.
Oh, there actually isn't even any output. So these are the logs for the controller, and there's nothing there. There's just an error. But usually you'll see, like here, I'll show you the give.gt controller. Uh, it's quite verbose, and it tells you what it's doing. So here I have a game resource. I'll show you what one of those is like.
And just for quick context for people watching, give.gg is your Doom WAD multiplayer.
Yep. Yeah, so we need to host individual pods for each server. And as you can see here, there's 3 servers, right? So we're going to do get game, kubectl get game. I have kubectl alias to Kane just for shorthand.
Yeah.
Here they are. And those IDs correspond to the server ID.
Yeah.
Or the game ID. Let's look at the pods, that namespace as well. And you can see here are the game pods. So the downloader can, let's back up. The pods can have multiple containers inside of them. This is it's a well-known feature of Kubernetes, but until you really appreciate how powerful it is, you're probably not going to use it. But wow, it's nice. So in this one pod, I've got 4 containers here. This first container is what's called an init container, and that's actually downloading all of the. Or let me zoom in. Zoom in. It's actually downloading all of the WAD files, like the iWADs, that it needs to run the game.
Yeah.
And it downloads them from S3. The server container itself just runs the game. That's your standard Xandrona server. Proxy is the live kit to UDP proxy, because the game server only understands UDP, right? With Doom networking, you connect over UDP, and that's how you send and receive packets to the game server. But because it's in a browser, I need to connect clients over LiveKit, which is this really nice piece of software for doing all sorts of things with WebRTC. One of them being like real-time data operations.
Yeah.
So the proxy is a WebRTC to UDP thing. Here, let me show you. It's actually pretty simple. It's like one file right here. Player session, when a player connects, creates a little player session, stores it in a map. Here we go. Here's the main event loop. Receiving a UDP package, we just publish it to LiveKit, right?
Yeah, that is pretty simple. Yeah.
In the room associated with the game. Here are all the events. When a player joins the room, that's the equivalent of like connecting to the LiveKit server via the browser. So this ensure player session function creates all of the resources that you need, like the UDP connection and all that. A little log statement here showing when a player connects. So we're just piping packets back and forth between UDP and LiveKit with this little service, and it runs in a sidecar. So that way you can just connect directly to LiveKit, and this server proxy is also connected to LiveKit, and that's how you get communication. The spectator container is for this stuff right here, which doesn't seem to be working. There's a bug I need to get figured out. I'm not sure what it is, but yeah, let me kill these. And so right there, just so everybody knows what's going on, in K9S, if you highlight a pod and hit Control D, you can delete it, which is really nice. And if you specify force, it won't even give it time for graceful shutdown. It'll just immediately kill it, which is really nice. I use that all the time.
And then is the controller spinning up another instance of that service?
Yep, that's this right here, Dorch operator.
Yeah.
You can see that it's a little, we do this. There we go. That's a little bit better contrast here. So yeah, you can see when we deleted the pod, uh, it detected that change in the pod resource and it issued the terminating action to the controller. The controller is divided into a read phase and a write phase. And this is the reconciliation loop. So in the world of automation, reconciliation loops are all the rage. The idea is you have a desired state, you have a current state, and then you do stepwise reconciliation of that, where you're kind of like issuing these imperative commands. And that is the paradigm that bridges your imperative API. Like, for example, Kubernetes has this API for deleting a pod, right? That I just demonstrated, like that. Well, the controller determines how to drive the Kubernetes API based on the difference between the desired state and the current state.
Right. I see. Yeah.
Yeah, like here's all the possible actions that the controller can do. You can create the pod. If the pod is in the pending state, then the controller puts the game resource in the pending state. I try to make the controller status mirror get game dash. I try to make it mirror the pod, this phase right here in the age.
Yeah.
That way, you can only look at the game resource. You don't actually have to look at the pod resource, right?
Yeah.
The delete pod, that action is called whenever, let's say, the game crashes. The pod will be in an unhealthy state, and the controller will delete it and then recreate it. So it'll run delete pod and then it runs create pod.
Yeah.
But the delete action right here, that's actually going to delete the gain resource, and that runs if a server has not seen any player activity for 5 minutes. So it's like a garbage collection mechanism for user create, because you can come in here and oh not did we freeze? Goodness, I've got a bug in the front end. Can't even type. There we go. So you can come in here and like create your own maps, call it whatever. Enable, oh, that's single player. So if we want multiplayer, we'll disable that. Maximum number of active servers reach. Looks like I'm going to have to delete a server. Actually, we'll just increase that because I want to have. That's a bug. Save that for later. So yeah, that's what give.gg is doing that's kind of unique is it's got this
Yeah, yeah.
uh, controller here for
And it's amazing you're able to customize the controller to that degree. You could really set up anything you want.
oh yeah, and the resources are oh garbage collected when you delete. Like here's an example. If I have this open, so you see K9S in the background, right? So we'll do K get Kane dash n Dorch. Okay. I'm gonna delete this guy right here. K delete thing right there. And then you see it deleted the pod, right? And that's because the pod has an ownership reference to that game resource. So whenever you delete the parent, it also deletes the child resources. Super useful. You can create all sorts of garbage, secrets, services, deployments, an entire stack. And then when you delete that parent resource, it cascades.
Yeah, yeah. This seems like basically essential if you're moving to kind of the next level in your developer journey and you're making things that are more complicated than could be hosted on Vercel pre-config things. Like if you need that much control, this seems basically essential.
Oh, yeah. Like this is pretty nice, compared to the way that people were running systems at scale pre-Kubernetes. I mean, there are some really good tools that were developed alongside Kate's that solve a lot of the same issues, but Kate's does a really good job of offering like a coherent experience.
Yeah.
And with the way cloud providers now offer managed Kubernetes, they just make it so easy.
Yeah.
And like it's great. If I just come to my DigitalOcean control panel, go to Kubernetes, if I want to spin up another cluster, I just hit that.
Yeah.
There you go. I can create anything as big as I want. And then for adding nodes to the cluster, so here we have, I'm going to change hold on, my fiance is calling me twice, which usually means it's super important.
All right. Yeah, we can always cut. We're helping you guys host the infrastructure. You will surveil us. I mean, it'll be surveillance in like the most helpful form of the word. Like I think we can make some great little tools. Like having a web extension injecting on top of Discord, giving you a summary of exactly who you're talking to is so nice. Or like having a Nemo spot, being able to tag it and say like, yo, do you know, is anyone an expert on this? And then you can find their all their chat history and stuff that can direct you to like, oh yeah, this person did have a problem with, I don't know, engine X. Here's the forum post. They're talking about how to configure it with their resources. Like, it'll just be so nice to have that all in a database where we can vector search over, especially for like more obscure information. I feel like people know they have certain hacks that are hard to find, and yeah, it'll be cool for networking as well. Like looking to pair program with someone that'll pull up everyone who knows Golang. Someone also suggested we could make it more like a surveillance bot, and whenever anyone sends a message, or we could use call logging too, we could like keep track of like how do like analysis on how engaged they were and how energetic they were. Keep track of like people's contributions to things, and then like have a merit system that way. Like, uh, I'm looking for someone who's very active, and then it'll tag Finn or something. I think this like immediately the coolest thing that'll come out of it is just summaries of people. and that'll just have like long-term like use cases we can tap into for many projects in the future because uh yeah, I don't know, like if we ever want to, I don't know, there's just lots of projects that could tap into having like a unified anyone spending too long in insert mode. Yeah. Or keeping track of statistics about people could become very useful if someone like Carlos, who's in a position of eventually like looking for people to employ, you could have like a very easy search, like, here's the top 5 developers in this thing and by contribution, who is the most enthusiastic and is known to be good to work with. Yeah.
Sorry about that. My fiance is having a little bit of an acute health thing.
All good.
Yeah, I'm wondering what she should do.
Yeah, being in a position to like knowing medical stuff seems very practical just outside of the job.
Dude, I have to like fight family members and family friends away with a bat.
Really asking for advice.
Yeah, like medical advice. Yeah. What do you think this is? And like I can give them information, like knowledge is power and there's no issue there.
Yeah.
But like, man, like please like go to a doctor, like go to a specialist. A lot of people don't even know how to like properly utilize the medical apparatus.
Yeah. I mean, it is kind of a dinosaur, I feel like. It's at least in my experience with like the psych ward, like there's just so much bureaucracy and it moves very slowly, which might be off-putting for some people.
Oh, definitely. It's like institutionalized suffering.
Yeah, it really is.
I hope and pray for a new paradigm sooner rather than later. Uh, but even like to this day, I'm constantly finding out what different specialties are really able to do. It's like neurology has changed quite a bit since I last took a look at it. They're able to do a lot more than they were even a decade ago.
Yeah. Yeah, I bet. Um, yeah, so on top of the medical stuff, you got Kubernetes knowledge as well. That probably puts you in a very small minority, like you were saying.
Yeah, I mean, I don't know anybody in med school that even writes code. No, I have family asking for medical and Kubernetes advice. I don't think anybody's asking me. There are a couple people in my lab that ask Kubernetes questions, but it's pretty niche even among developers. It shouldn't be. I feel like we need to push it because
Yeah.
more. It's a really good way to get into distributed systems.
I mean, hopefully that's what this video will do. Hopefully it'll encourage a bunch of juniors to learn.
Play gib.gg. That's my Doom advice.
Yeah. I feel like there's someone else in this server who's in medical software too. I forget their name, but I guess I worked with my first kind of internship experiences was working with like vascular surgeons on retrieval augmented generation for vascular research. That was like it was right at the start of when RAG techniques were coming out though. It was kind of early days for AI.
Vascular surgery is intense.
Yeah, yeah. Yeah. But I remember one of the guys there was, I don't know what it is if people are like on a self-actualized learning path and they're able to learn multiple difficult things, but yeah, one of those vascular surgeons like was fully a Vim user and knew way more than he should have honestly about computer science.
Carlos said, I'm still stuck on ECS deployed via CDK. So that's the problem is vendor lock-in. Like they sell you on using the vendor specific tools by reducing complexity. And then before you know it, the development cost, if it's even remotely feasible to migrate to another cloud vendor, the development costs are going to be like substantial. You're going to be spending weeks or maybe even months doing the migration.
Yeah.
They rely on that.
Yeah.
Yeah, egress costs can get substantial on Amazon as well. On DigitalOcean, the egress costs are marginal.
What's kind of the cost for hosting like small to medium projects on compared to doing something like AWS or another cloud provider?
If you are wanting to go cheap, uh, you can get it done on DigitalOcean for maybe $30 a month. Let's take a look. It should be about $15 for the Kubernetes node. You get a free control plane. Let's see here. Don't want high availability. $12 a month. It's even cheaper.
That's pretty good.
This node, $12 a month. And then let's see how much they're charging for a load balancer here. Or is it $12? Okay, so it's like $24 a month. And then if you're wanting to store files, Spaces is $5 a month, but you get quite a bit of free storage, free quote unquote. And the storage costs are included up to a pretty significant number of gigabytes. So yeah, probably like $30 a month, all things said and done. How much does GoDaddy charge for hosting a small website? It's got to be more expensive than that. Typically charges about $8.99 a month when you commit to a 3-year term. See, that's the problem.
Yeah.
Yeah. You pay month to month. How much does it ever be? I mean, if it's only like $9 a month and you're paying for 3 years, that's like $72 for all that hosting. But the problem is like, okay, how do you scale that up? How much is it going to cost you when you scale it up? What if you have more sophisticated hosting requirements? Like with Kubernetes, you can literally just do whatever you want. It's like a sandbox. And yeah, there is an investment in like learning Kubernetes, but once you're there, you can do it for any project. Like, we ported that 1984 bot to Kubernetes in like what, an hour?
Yeah.
You were learning how to do it at the same time. So, if you're well versed in Kubernetes, then you could do that in 15 minutes, get it deployed.
Right. Yeah. Especially if you're just copying over files and tweaking your Docker files slightly. Yeah.
There's a lot of that
Yeah.
for sure.
Yeah. That seems like a perfect use case for Unis's like Jimmy bot. You could have like a auto deployer script that throws all the Docker files and chart files together for you.
You see those chat Jimmy.
Yeah. Well, actually, um, we don't want to leak that API to the wider public yet. 'Cause
Oh, chat Jimmy.
we got to keep that as a super secret.
Got it. Let's
Yeah.
see for it.
Yeah.
Looks like it's down.
Oh man, Eunice killed it. Yeah, I mean that's basically like a wrap on the video. I feel like that covers most of the philosophy. I think it's
We could do one more little section here if you want to.
sure, yeah, yeah.
This is so like the benefit of running on Kubernetes.
Are you still sharing your screen?
Do yeah, am I?
Just getting, let me reload.
I might not be.
You were a second ago.
Yeah, I wonder where it went. I don't see the tab open anymore. Let me see. Do I just like click on? Oh, I might need to send you a new link.
Here's this link. You
Talk about that. I have no idea how that ended up happening.
Yeah, no problem.
There you go.
Sweet.
New link.
This service, this dead simple screen sharing is pretty good.
Oh, it's sick, man. I didn't even know you could do screen sharing from the browser like that. Okay, you able to see this?
Yes.
Okay, so event-driven architecture is really nice when you have a bunch of like asynchronous batch work that you need to do. And I have a NATS cluster running in my Kubernetes cluster that I use all this.
You're just sharing your Discord right now. You might wanna,
Really?
if you're sharing your terminal, yeah. There we go.
Oh man, I hit the wrong screen to share or selected the wrong one. Let's try that.
There we go. Yeah.
Okay, yeah, so here we have the NATS cluster on Kubernetes. You can scale it up pretty easily. I've gone 3 nodes, so like clustered NATS. That's trivial to get set up. But NATS is the message broker that I'm using these days for event-driven architecture and other communications. So like here in the Dorch namespace for give.gg, this archiver microservice, it's not running right now because I run it on its own like node, so that way it gets dedicated compute resources. But this service pulls from a stream on NATS. It's NATS Jetstream, and processes the message and acts the message after it's done. So this handler for Dorch Archiver, it's totally event driven. It can handle, thousands and thousands of pending job items in the same queue. I can spin up multiple replicas of that. I've had it where I had 8 of these Dorch Archiver pods going at the same time. All of them were reaching out to OpenAI to do the analysis. I'm taking screenshots from within the map, and all of that goes through NATS. Then whenever, the analysis is done, I do an HTTP post request to WAD which is like my central monolith.
Yeah.
So yeah, having a NATS Jetstream cluster in your K8s cluster, that really just kind of eases the friction when you're trying to introduce some sort of event-driven workflow into your platform.
Yeah, yeah.
Yeah, same thing with monitoring visibility. I have this in the monitoring namespace. This is the Cube Prometheus community stack. It's a simple Helm chart that you install, and that's what gives us grafana.beebs.dev with all those dashboards and stuff.
Wow. Yeah, yeah, yeah. Yeah, that is amazing. Yeah.
So it's I really like this because, man, like you're wondering what the heck is going on with your cluster. You really need something like this.
Yeah.
Here's per namespace. So as you can see, the 1984 bot is like using almost no CPU,
Yeah.
but the Python service is busier at idle. Here's the memory footprint at idle. Real nice. Set up a silly bandway. Yeah. So there are all sorts of cool software packages you can install on your cluster to give you stuff like this. Like here's external secrets. You use that to project a secret from one namespace into another.
Oh, that's
Like example, yeah, Keycloak is going to generate its own secret for the admin password, right?
yeah.
And you can project that into your own namespace so that way your own code can use it. And if it ever changes, if Keycloak ever deletes that secret and recreates it, it automatically updates it in your namespace as well.
Right. Yeah. Wow, that's incredibly useful.
There's LiveKit that's for WebRTC stuff. And I'm using SRS. What is it like? Simple something server, simple relay server, maybe. That's for the RTMP and HLS streams. I did write Strim. If you remember, that's in my portfolio,
Yeah.
which is an HLS streaming backend. But DigitalOcean Spaces doesn't allow you to configure the caching headers and the response that make it work. So unfortunately,
Yeah.
stuck with it. But the upside of SRS is that it works beautifully. You can plug in an RTMP stream and you get HLS and WebRTC out of it.
Oh, yeah, yeah.
And the CPU usage is, yeah, like not bad. You see this, it's encoding a video here. It's only using 7% CPU, 870 megabytes of memory.
Yeah.
Not normal. It's mostly a memory cost.
Yeah. Yeah.
Yeah, so having it all in one place. Here is ingress. We use traffic ingress. I can't show you these logs because we have a bunch of IP addresses in there.
Yeah.
But Vocari is Hugo's app.
Yeah. Yeah, and that's so nice. You can host other people's apps too. Yeah.
Yeah, Cert Manager, that is a piece of software that we use for getting a TLS certificate for HTTPS.
Mhm.
Really nice, really mature piece of software. I've been using it without drama for probably a solid like 6 or 7 years. Probably soon after I started using Kubernetes. It's really the official, quote unquote, official, unofficial way of getting certificates for HTTPS on Kubernetes. Kube system, that's going to be everything that DigitalOcean has to run on these nodes in order to keep the system working. So if you delete something from Kube system, it's just going to be recreated by the control plane.
Gotcha. And those are just random DigitalOcean infrastructure services.
Yeah, it's like the what do they call it? Container network interface, the VPS connection, if I remember correctly, like getting everything in the same network. I think that's bridge proxy. I'm not sure what node agent and DO CSI is. I think that's container storage interface, something like that. But yeah, it's basically drivers
Yeah.
for your nodes on the cluster. And if you were running an NVIDIA GPU cluster, you'd probably see, in fact, that's AnyQ GPU. I think I started my local Kubernetes cluster. So this is running locally on my computer here. I clean this up a little bit. When it's starting up, some of these pods and to have issues, especially the GPU pods. They get this unexpected admission error because Cube says, here we go. Yep, Cube system has NVIDIA device plugin daemon set, whatever,
Yeah.
for exposing your GPU to the cluster. And I have time slicing configured so I can run multiple pods using the same GPU.
Hmm.
It's kind of a fragile thing. They don't really design it for that. They kind of design it for one pod per GPU. But yeah, this is the Seer backend. I've got, as you can see, I'm not in the cloud anymore, so I'm running some of those amenities locally, like Postgres.
Right. Yeah.
Yeah, here's the Seer namespace. So many microservices for Seer. There's the audio to text, which is Whisper. It uses the Whisper models underneath the hood. This is for workflow coordination, Augur. Or Corpus stores the searchable entities, and that's ultimately going to be what you use to do the keyword search. Full text is a service that actually extracts the text directly from documents. Intake is where files go into, regardless of what file type it is. That's kind of the entry point for the data ingestion pipeline.
Yeah.
OCR for optical character recognition. PDF receives PDF files from intake. So it goes intake, PDF, and then renderer, which is going to render the PDF file pages to PNG images. PDF thumb is going to do that runs after renderer. So it renders like a very high resolution. I don't have anything rendering right now, but it's like, I don't know, like 3,000 plus pixels by 5,000 plus pixels.
Yeah.
The idea is to make it like much higher resolution than what a typical screen would display to give the optical character recognition the best possible chance of actually reading those characters.
Oh, yeah. That is very clever.
Yeah, PDF, man, it took so much massaging. OCR is fragile. That PDF scales that down into like, I think it's like 300 by however many pixels.
Yeah.
I think the minimum dimension is 300. Re-ranker, that is going to reorder the candidates. Screen sharing isn't working anymore for real, guy.
No, it's working. I can see this.
Okay, that's weird. Maybe I was reading a old message. Re-ranker is going to do the sorting after you have this giant list of candidates. So you're going to have some duplicate candidates. It uses neural re-ranking to give you the final rank of candidates. And then you apply deduplication because the same content might be indexed more than once, perhaps through direct text extraction, and then again through optical character recognition. So re-ranker and search work together here. You call the search API, it calls corpus, then it invokes Vald. As you can see here, Vald is the vector search engine that I'm currently using. It combines those results, it sends it to the re-ranker, it deduplicates, and then you get the search results.
It's a lot of microservices.
Yeah, for sure. Text to vec is basic like text embedding. Like you need to go from natural language to vector representation. Vec to index is going to, what was that? I think it indexes those vectors in the database. That I think that's like a write layer for the database. Video to audio just uses FFmpeg to extract the audio from a video.
Yeah.
If you have like a lecture video, you can get the audio from it and then send it to audio to text.
Right.
And then video thumb, same thing as PDF thumb, but it's using videos as input. Once again, all the heavy lifting done by FFmpeg.
Yeah.
Yeah, so that is power from many microservices. And then uh, Synapse is about the same number, a little more. Yeah, so a whole bunch of microservices. Dude, compiling this thing from scratch takes like hours, even on my computer.
Yeah. Yeah. I bet. Plus, it's like
Threads.
a lot of Rust too, which is not quick.
Brutal. Yeah, Rust is I still couldn't believe how long it took to compile that one microservice on your MacBook
Yeah.
cores. That was unconscionable.
Yeah. I mean, yeah, I guess to be fair, I'm not using the newest native container tooling, but still, I mean, just the Rust tool chain is kind of clunky.
I mean, what you're looking at 10% additional overhead if you're using quote unquote like ancient container tooling. It's for the most part, it's always been like a flat penalty that you pay for performance.
Yeah, that makes sense.
Dude, it was going on for like 30 minutes and it wasn't even done with the base image.
Yeah. Yeah. Um, I'm curious because you wrote that Tessera DB in Zig. Do you think a lot of people are talking about the Zig allocator paradigm being like also nicer to work with? Are you planning on like using the language for future projects at this scale? Or are you still on Rust?
Not at the scale. Uh, so when I was writing that Tessera DB, uh, I ran into a handful of memory management bugs just because that's the nature of the game when you're managing memory, and you're writing your code. Amps, I accidentally got a double free or a memory leak. And that kind of scared me away from as like a full replacement to Rust. All of these microservices, with few exceptions, are written in Rust. Zig is awesome, don't get me wrong, but when you really need like safety and alt tolerance and reliability more than you need that like extra 2 to 3% of performance, I feel like Rust wins out. Zig really wins if you have to do something really quickly and you don't care about leaking memory until the end of the compute task, because then you can do cool stuff like put all your allocations into a single arena and then just free the arena after you're done with that little batch job.
Right. Yeah.
It's kind of like turning I've done this before where I have like a garbage collected language that I run as a script whenever a handler gets invoked. Have like an event-driven architecture where a microservice gets a message and then it runs like a Python script or something like that. And if the overhead of garbage collection is for some niche reason uh, not benefiting you, you can, pretty sure anyway. Man, I might be talking out my ass here, but I'm pretty sure at one point I tried disabling garbage collection in Python. I don't think it really got anything for me, but you can do stuff like that. Those are options that you have when you structure your code that way. Hey, I don't need to worry about garbage collection. I just need to get this work done as quickly as possible. Then I'm going to free everything after I'm done with the work. And that is not really an option in Rust, unfortunately.
Right.
Very natural in Zig. That's like stuff like that is native to Zig with the Arena allocator. So yeah, I really like it. I wish the Nats experience in Zig would be better. There are a couple projects that are like in their infancy and or not maintained. So I haven't been able to get that working.
Gotcha.
But yeah, it's fun. I like using new languages.
Yeah, 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 totally. Wow, another great session of learning about Kubernetes. There's a lot in there. Yeah.
I will analyze it at every opportunity.